Good afternoon, ladies and gentlemen. As they said, I'm the last speaker. So I will try not to bore you with some other technicalities. But as they indicated, my research is on natural language processing. My focus is on low-resourced languages. I believe quite a number of you have utilized a Google API to do some translation. Anyone that has not used Google API to do a translation? Wow, I'm the only one that have used Google API. That's good. So the challenge that we have with the Google API, not only the Google API, but most of the translation softwares, they cannot disambiguate polysemous words, especially in the indigenous languages. I'll just give an example here. We have a sentence in Northern Sotho, and this sentence says, Nokayama ebotlhoko. The correct translation is, my mother's hip is painful. But what we get from the machine translation, especially the Google API, it says, my mother's river is painful, which is a wrong translation. The second sentence says, Noka etletse metsi, the river is full of water, which is correct. The last one says, ke noka seshibo ka letswai, meaning I'm seasoning the side with a grain of salt. But the API says, I take gossip with a grain of salt. One of the reasons it is unable to translate is because it doesn't understand the polysemous words in the indigenous languages. So our research is based on assisting the machine to understand polysemous words in the language. Although our focus is in Sesotho sa Leboa, which is mostly spoken in Limpopo, but the same principle can be applied to any South African languages. So, as they indicated earlier on, data scarcity is something else. Finding enough high-quality parallel data to train model is one of the biggest challenges. I believe I have already indicated my problem, which is basically on word sense disambiguation, which is basically how you can determine the correct meaning of a word in a particular context. So our research investigated the potential of a transformer-based model and deep learning architectures to address the word sense disambiguation problem. One of the examples in word sense disambiguation is most of the current language models, they typically assign a single representation to each word. We have the word bank referring to the river bank, and we have the word bank referring to the financial institution. But the language models will assign a single representation to each word. That's why it is difficult for the machine to disambiguate these words. Again, we have a limitation of token level prediction in the language models, and it raises a question of whether these models can effectively handle polysemy and word sense disambiguation. And we have moved away also from the conventional or traditional machine learning. We talk about the large language models using deep learning. We also talk about transformer-based architectures. Basically, those are a breakthrough in computational linguistics. They are central to resolving the problem that I indicated earlier on. We have also moved to use large language models with the deep learning, and I have indicated some of them in my diagram there, like Biagru, which is one of the deep learning models, and also I've indicated the BiLSTM, which is a bidirectional language model that can be utilized to resolve the same problem. This is basically our research methodology. Our study basically utilizes data set from SADILA, South African Center for Digital Language Resources. We have access through a targeted search for Sesotho sa Leboa, and we also decided to build our own data set to supplement what we have. Unfortunately, the language itself has more than 200 polysemous words. So we only worked with about 22 polysemous words, and we generated about 3,000 sentences. We created the corpus, and after this corpus was also compiled from dissertations, research papers. We applied web scraping. Most of the research papers and the dissertations were coming from the University of Pretoria. And we manually annotated them to balance both the breadth and the quality of the data. And we went through a pre-processing module and vector representation. So what we have here are the different large language models for the transformers. And we also have the deep learning models that we have. So in our research, we did a baseline experiment on each of these transformer models, and we also did a baseline experiment on each of these particular deep learning models. And after we decided to create a hybrid of each of this particular model in our experiment. And I will show later on that we enhanced the Biagru with different algorithms. We optimized it with Adam, which is an algorithm for optimization. We also applied attention mechanism to enhance this particular algorithm to get the better performance. So our data set consists of about 2,859 sentences, and we also have about 162 sense types and the 22 primary lemmas. The average ambiguity score was basically 4.85. For this particular experiment, we used Google Colab. We also leveraged on T4 GPU to accelerate the model training and fine-tuning processes. This is basically just to show a word cloud of all the sentences. As you can see, we have quite a number of words that are indicated in Northern Sotho, which basically are polysemous words. And this is a distribution of unique senses per word in our data set. And also, we had the outliers in our data set. So, outliers in our textual data set, such as unusual short or long sentences or uncommon sense labels, they create a skew model performance or introduce noise. So we had to detect if our data set has these outliers so that we can resolve them. So to resolve them, we made use of a mathematical formula. where we identified the outliers. And in case our outlier, which is our Z-score, is greater than 3, then we had to review the importance or adjust that particular sentence appropriately because it was creating the outliers. Now, this was basically the result of our baseline model. You can see by Agro here is a baseline model performed very well. It was followed by Berta under the transformer models. But basically these two were the highest performers in the deep learning model. But on the transformer, the highest was the Berta model. So you can see even on our model accuracy trends, by Agro was the highest. So what we did, we just experimented with the baseline in the first instance. Then after we enhanced the model, now bear in mind that we enhanced our by Agro model as identified in the previous slide to be the highest. So we decided to use an optimizer called ADAM, which is an algorithm to optimize the by Agro model, and it moved from 79 to 84%. We further decided to enhance the same model with attention mechanism, and it gave us an 85%. Then we decided to create the hybrid model of the by Agro and the transformer models, and the highest performance was on the hybrid that we created for by Agro and the Berta, which gave us 85%. But now, when we checked the robustness of the model, we realized that when we enhanced the by Agro with attention mechanism, the training loss and the validation loss, there was a gap which indicated that there is overfitting on this particular model. So we cannot actually rely on the by Agro enhancement, although the accuracy is very good. But when we came to the hybrid model that we created between the hybrid model between by Agro and the Berta, the accuracy was 85%, just like the enhanced by Agro, but our training loss was actually robust. So meaning we didn't have overfitting on that particular model. This particular study demonstrates the potential of transformer-based models and deep learning techniques for addressing word sense disambiguation challenges, specifically in low resource languages. Although we applied this only in Sesotho sa Leboa, but the same experiment can be performed in any Bantu languages. This advancement holds promise for improving natural language processing capabilities for underrepresented language globally. In future, we also want to look at the data augmentation, and further, we also want to continue to fine-tune our models with different learning rates and batch sizes. We believe that we can enhance the performance of these particular models. In conclusion, this particular research is very significant for the progress in addressing the problem of word sense disambiguation in low resource languages. Advanced models like by Agro and Berta show great potential, while even lightweight models demonstrate promising results. The findings pave the way for future research and development, contributing to the advancement of natural language capabilities for the low-resourced languages. I thank you for the time that you gave unto me for the presentation.
Thank you.
Thank you.
This is for Yes, that's the last presenter, and very interesting, you can see.